Hi, welcome to Coding with Doc. In this sequence of lessons, what we're going to do over 8 sessions is go through the basics of how we code in Python. And the aim of that is that by the end of it, you'll have a very practical working knowledge of how to make a sequence of code, how to do a choice in terms of make a decision to go one way or to go the other, and also to have an understanding of the concept of loops in a program. And there are lots of reasons why you might want to loop things around. Now, those 3 basic ideas, a sequence, a selection, and a loop, or what we might call iteration, are the most important logical constructs in the whole of coding. Now, the first question most people ask me when we say we're coding in Python is, what's Python? So you might have done things like this previously, which is EduBlocks, or you might have done things with regard to Scratch, where it's all very drag and drop. Python's a bit different. Python's a proper full programming language. It allows you to make apps. You can write program apps, you can write programs themselves, and there are lots of real-world jobs coding in Python. Now, the first question you'll probably have is, why is it called Python? What on earth is this language? And why are we using things like Tkinter or Trinket to be able to code? Why are we using things like idle, and why is it called idle? And for all that, I'm going to go to a video by a guy called Guido van Rossum, who was the man that actually made Python in the first place.
I was a big fan of Monty Python, and I thought that the existing sort of patterns for naming languages, like acronyms or famous people or even mythology, were boring. I wanted to counteract that as a tiny act of rebellion with something from pop culture. Plus, Python is a 6-letter word. It's pretty easy to type. It's very easy to remember because it has all these other connotations of snakes and comedy. Python's community is a fantastic thing. It's a great resource. It's a place where people can get help with projects. It's also a very diverse place. I worked hard on that. Or again, I mostly encourage the community to do more of that.
Behind me on the screen, you can see that I've loaded a copy of Python itself. Now, on this side of the screen, you've got the program window. On that side of the screen, you've got the display window. And when you first load Python, if you're using idle rather than Trinket, you'll need to go to File and New in order for it to come up. And the other thing that sometimes people want to do is have line numbers. Now, not all my lessons that I'll do with you will have the line numbers on, but if you want line numbers, you just go to Options and put line numbers. And equally, if you find the text is too small, just click on Options and go to line numbers, and it'll let you change the size of the text. So that just gives you a little bit of control of the environment itself. Now, all these sessions, we're going to use a methodology called PRIMM. And you're going to sit there and say, what's PRIMM and why is PRIMM useful? So this is PRIMM. In this series, we will be using the PRIMM methodology for looking at programming. And that methodology runs through these 5 steps in each session. So the first step is to be able to look at code and just read it. Say, what do I think that code does? The second step, to be able to pause the video, copy me, write down and copy out code as I've done it on the screen. The third, play with it, investigate it, and I'll do some of that with you alive on the screen. Next step, pause the video again, modify, make changes, try and solve specific questions. And then the last step, be able to make code on your own, to be able to make code independently. Now, clearly, each of those sessions will be leading up to a make at the end of each session that is designed to enable you to be able to do this independently on your own. Turning to the first exercise, I now want to look with you at the idea of programs themselves. But before we start practically writing them bit of code, as we will before the end of the session, what I want to look at is some of the ideas behind it and use things called algorithms. One of the core concepts in programming is the idea of an algorithm. So an algorithm is a simple step-by-step set of instructions for performing a task. And that's where I want to start this particular exercise. I want you to get either a piece of paper and a pen or a mini whiteboard, and on it, I simply want you to write a set of instructions that you might give somebody else, anybody else, so they can make you a cup of tea. And the aim is to make those instructions as clear as possible so that everybody would make the same cup of tea. And while you're busy doing that, we'll just have a few words from our sponsors. Now, welcome back. So you might have done something that's like what you see on the right, where it says, here's a set of instructions, this is how to make a cup of tea, and it's given you take a tea bag, boil the water, etc., 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 down, and you've put all those instructions together. Or you might have done it the way that I've done it on the left. You might have tried to use one of these sort of formal structures for giving sets of instructions. Now, this particular one is called a flow chart. And on this flow chart, in square boxes, we've put things that you might do. And in a diamond, we've put things that you might ask, decisions. So it says, boil the kettle, fetch the tea bag, pour the water, ask them, do they want sugar? And if they do, go down one arrow to add sugar and then go to the milk question. Or if they don't, go straight to the milk question. And same with the milk question, then drink a cup of tea. Now, some of you will have sit there and think, but you missed things like the type of tea bag, because if it was green tea, you might not offer to put milk in it, or, some of you might have strong views about whether you put milk in first or you put the water in first. Yeah, different people have different strengths of opinion on that sort of thing. But the basic idea behind all this is that we are writing a set of instructions, an algorithm. And the aim of an algorithm is that you can give an algorithm to anybody else, whether it's written out, whether it's a set of instructions, whether it's a diagram, or whether, as we'll find on this unit, it's written as a piece of code. And that algorithm, when it's operated, is accurate. It always does what it's meant to do. It's consistent. It always produces the same result. And it's efficient. It doesn't do things that we don't need to do. Now, the challenge of writing any algorithm is those bottom three words. Can you make what you do accurate, consistent, and efficient? Can you stop your instructions being misinterpreted by somebody else? And I want to turn to something that's going to illustrate that. Let's watch a short clip. And this clip, a father is demonstrating to his children how it's difficult to write a set of instructions that's really precise.
You're not making any sense. He's already ruined it on purpose. He knows how to make one.
What's up, the internet? You know what? I'm hungry. I could really go for a peanut butter and jelly sandwich. Do you guys think you can write down some instructions and teach me how to make a peanut butter and jelly sandwich?
Yeah.
Then do it.
I knew we were gonna do this. I heard Dad talking to Mom.
Choke yourself on my hand. Sometimes they do what you tell them.
Dad, I'm done.
Step 1. Get 2 pieces of bread out. Got 'em. Get a butter knife and get some PB. Take 1 piece of bread, spread it around with the butter knife.
No, Dad, with the peanut butter.
I'm just doing what it says. It says take 1 piece of bread, spread it around with the butter knife.
Hold on.
Get some jelly, rub it on the other half of the bread.
No, Dad, open the jelly.
Well, it doesn't say to do that. Put the breads together on top of each other. Take a big bite. This doesn't taste like a peanut butter and jelly sandwich. Fail.
Yeah. Oh, yeah. Sorry, I had to make it extremely specific.
Oh, good. I'm starving. Take 2 pieces of white bread out of the bag. Take the lid off the jar of peanut butter. Get a butter knife and stick it inside of the peanut butter jar. With the knife, scoop a bit of peanut butter out
A bit,
of the...
that means like a lot.
A bit means a lot?
In my world.
Spread your scoop of peanut butter onto one of your pieces of bread with the knife. All right. There we go.
You're doing better than before, though.
Open the jelly jar. Squeeze it onto the other piece of bread.
Nope.
Done. Closer. Get 2 pieces bread. Get some peanut butter. Take the peanut butter knife. Open the peanut butter. Put the knife in the PB. Get some jelly. Open the jelly.
No.
Squirt the jelly onto the bread.
You're supposed to.
Take the butter knife with the peanut butter on it. Wipe it all over the piece of bread that's blank. Take the butter knife, rub the jelly all over the piece of bread.
Oh, he's doing better. Oh.
It says all over. Put the 2 pieces on top of each other.
This isn't how I meant.
Take 2 pieces of white bread out of the bag. Take the lid off the jar of peanut butter. Get a butter knife and stick it inside of the peanut butter jar. With the knife, scoop some of the peanut butter out of the inside of the jar. Spread your scoop of peanut butter onto one of your pieces of bread with a knife.
No.
Squeeze some jelly onto the other piece of bread. Spread the jelly on the bread with the butter knife. Put your 2 pieces of bread, peanut butter and jelly sides together. Done. Get 2 pieces of bread. Get some peanut butter. Get some jelly. Open the peanut butter. Get a butter knife. Put the butter knife in the peanut butter. Take the butter knife out of the peanut butter.
You did it wrong. No.
Take 1 piece of bread and take the butter knife that has the peanut butter on it and spread it all over the top of the piece of bread.
Dad,
That's the top.
I mean the sides.
Squirt some on another piece of bread. Take the butter knife, rub it all over the top of the piece of bread.
I quit. You're not making any sense. Sorry, you ruined it on purpose. He knows how to make one. I know, Evan. It's the joke. It's the game that we're playing. Oh.
Do you know how to eat a piece of bread? You want to take your sandwich with you?
Oh, this is really so good.
It looks like a yummy sandwich. I'm glad I made that for you.
Can I not save one with it?
Yeah, go take that one to mommy.
Okay. I edited a bit.
Take 2 pieces of white bread. Take the lid off the jar of peanut butter. Get a butter knife and stick it inside of the peanut butter jar. With the knife, scoop some of the peanut butter out of the inside of the jar. Spread your scoop of peanut butter onto the face of one of your pieces of bread with the knife. Squeeze some jelly onto the other piece of bread. Spread the jelly on the bread with the butter knife. Put your 2 pieces of bread, peanut butter and jelly sides together. Done.
Now eat it.
Not the best,
Well, you made it.
but
so
I think it qualifies. That's a win.
Woohoo!
Well, Evan and Jonna, did that go as you expected?
Yes. I expected to win.
Well, you sort of won. But really, I feel like we were all losers.
Now, for this next exercise, what we're going to do is look at that skill which we were talking about with PRIMM, about predicting. So the only thing I want you doing at this point in time is just looking at the code, reading it, and trying to make sense of it. So the first kind of programming work I want to do with you is to do some of these predict exercises. And I want you to think, to begin with, what would that do in Scratch? And I'll pause while you do that, and we'll just have a moment. And the answer is, the little cat in Scratch would say, hello, you're a lovely group. To do a speech mark. So then, let's try another one. Now remember, you don't have to know the answers to these. What do you think that would do if we did that inside EduBlocks? And the answer to that is, it would bring up the words, hello, you're a lovely class. So this print command is putting something onto the screen. Let's try another one. If I type that command, now let me just move the little thing out of the way. If I type that command inside Python, what do you think that would do? And again, you'd be right. It puts in, hello, you're a lovely class, in text. So you can see each of those are giving you a chance to just look at something and predict. Hi. Now, on this next bit, what I want to do now is look at this whole idea of programming itself. So you've been looking at this code inside Scratch or inside EduBlocks, and we know we're going on in this session to do some full code inside Python itself, either using idle or I'll actually use Trinket, which is online and it works better on things like iPads and things like that. But before I do that, I want to watch a video that came out a few years ago from an organisation called Hour of Code, which was a real push out in the United States to get children able to code, learning to code, seeing the benefits that code had for those. And I want to watch that video first because it's quite good at getting the message across about why coding matters. So let's turn to the video now.
What do you want to be when you grow up, Olivia? An astronaut.
I want to be a fashion designer.
A basketball player.
I want to be an actor.
A doctor. A teacher.
A chef.
An artist. What do you want to be when you grow up? A mermaid.
Do you know what a computer programmer is?
Yeah, no. No.
No.
I think it's something that has codes and is able to decode a mystery.
I think that they...
Wait, what?
Computer programmer?
No.
Nowadays, just about everything requires some form of programming. So, what is it? Programming is basically explaining to a computer what you want it to do for you.
When you're programming, you're teaching possibly the stupidest thing in the entire universe, a computer, how to do something.
Programming is one of the only things in the world that you can do where you can sit down and just make something completely new from scratch, you know, whatever you want.
It's really not unlike kind of playing an instrument or something, or playing a sport. It starts out being very intimidating, but you kind of get the hang of it over time.
Coding is something that can be learned, and I know it can be intimidating. A lot of things are intimidating, but what isn't?
A lot of the coding that people do is actually fairly simple. It's more about the process of breaking down problems than sort of coming up with complicated algorithms as people traditionally think about it.
Well, if it's fairly simple, why aren't there more of us doing it? Over the next 10 years, there will be 1.4 million jobs in computer science, and only about 400,000 grads qualified for those jobs. That's a shortage of 1 million people. So, how do you start?
I was obsessed with maps when I was a kid, and cities specifically. So I taught myself how to program. I had a very clear goal of what I wanted to do, which is to see a map of the city on my screen and play with it. Put things on the map, move things around the map. See what was happening in the city, how it worked, how it lived, how it breathed.
The first program I wrote asked things like, what's your favorite color? Or how old are you?
I first learned how to make a green circle and a red square appear on the screen.
The first time I actually had something come up and say, hello world, and I made a computer do that. It was just astonishing.
When I finally learned a little bit of programming, that blank wall resolved into a bunch of doors. And you open them, and finally you start to open enough doors that the light comes in. And to me, a finished program is like a structure filled with light. All the corners are illuminated. You understand the structure of it. It's a really serene feeling to have completed that.
It took me some time to realize that creating things with your hands or creating code, creating programs, is just a different way to express creativity. I think right now there's a big emergence of the culture of making. People who make their own scarves and hats, people who write their own apps.
Now it's just limited by your imagination and sort of what kinds of ideas what kind of understanding can you build into the computer so that it can do these things that were previously impossible?
All great things are built in teams when you collaborate with other smart people.
You're testing your ideas, you're stimulating each other. That's what makes us successful. It's not some flash of brilliance by somebody who then codes 24 hours a day for 3 weeks. It's what happened. The magic happens when we're all on the same page, collaborating and building something together.
There's a much greater need in the world for engineers and people who can write code than there will ever be supply. And so we all live these very charmed lives. To get the very best people, we try to make the office as awesome as possible.
We have a fantastic chef,
Free food,
breakfast, lunch, and dinner.
free laundry,
snacks, even places to play and video games and scooters. There's all these kind of interesting things around the office and places where people can play or relax or go to think or play music or be creative.
I went on the Bureau of Labor Statistics for the United States, and there's about a third of the pie that's all the things you would expect. It's they're working in the government, they're working in typical technology jobs, but then like the rest of the pie, and it was the majority of the pie, just split down into these little teeny slices of every industry imaginable. And what it is computers are everywhere. You want to work in agriculture? Do you want to work in entertainment? Do you want to work in manufacturing? It's just all over.
Here we are, 2013. We all depend on technology to communicate, to bank, information, and none of us know how to read and write code.
I was in this after-school group called the Whiz Kids, and when people found out, they laughed at me and, all these things. And I'm like, man, I don't care. I think it's cool, and, I'm learning a lot, and some of my friends have jobs.
It's important for these kids. It should be mandatory to be a citizen on this planet. to read and write code.
I just think you have to start small, right? And I think that's one of the biggest misconceptions about computer science and programming overall is that you have to learn this big body of information before you can do anything.
You don't have to be a genius to know how to code. You need to be determined.
Addition, subtraction, that's about it.
You should probably know your multiplication tables.
You don't have to be a genius to code. Do you have to be a genius to read? Do you have to be a genius to do math? No? No? I think if someone had told me that software is really about humanity, that it's really about helping people by using computer technology, it would have changed my outlook a lot earlier.
Whether you're trying to make a lot of money or whether you just want to change the world, computer programming is an incredibly empowering skill to learn.
To be able to actually come up with an idea and then see it in your hands and then be able to press a button and have it be in millions of people's hands. I think we're the first generation in the world that's really ever had that kind of experience.
The programmers of tomorrow are the wizards of the future. You know, you're going to look like you have magic powers compared to everybody else.
I think it's amazing. I think it's the closest thing we have to a superpower.
Great coders are today's rock stars. That's it.
Having watched that video, it's now time to start doing some coding. And we're going to do that coding inside Trinket. So, up till now, we've been talking about coding, but we've not been doing much coding. And so what I'd like to do is to start doing some of that. Now, we can use Python in a lot of different ways. The way you can use it, if you choose, is you can download Python onto your computer, and use a package like idle. And it'll install and it's free and you can download that and you can put it on. There are other online solutions like REPL and others like Trinket. Now, Trinket's the one I'm going to use today for no particular reason, but Trinket is free, so I've signed into Trinket, and inside Trinket I can click on Trinket. So this is just trinket.io.home, and you can load up Trinket yourself. You can pause me while you do this if you wish. And then you're going to go on to New Trinket, and under New Trinket, you're going to choose Python. So New Trinket and Python. And as you go into Trinket, what you've got is a screen that's divided into two halves. This side of the screen, which is your programming window, and this side of the screen, which is how it would appear if you ran that program. So we write the text here on the left-hand side, and it appears here on the right-hand side. So those are the two kind of differences. Now, when you program on say, idle on the computer, you'll have to go File and New, and you'll get the programming window that we've got there on the left-hand side. What idle gives you when you first load it up is the programming window. So that gives you that start. Now, to begin with, I want to simply do a run command where you can copy me. So some run exercise like we were talking about with PRIMM, and I simply want to try this command: print hello world. And I simply want to type that out and to then choose that run option that you can see there and just see what happens. And you can see as I do that, it puts the words hello world on the right hand side of the screen. And you know, it's often many people's first real program in text. Now, just investigating that, just looking at that, do we need the brackets? So does it need the brackets in order to run? So if we run that, it would seem, let's see if we change hello world to say hello Andrew. You can see it works without the brackets. What happens if I change the shape of the brackets? So I put it in square brackets, for example, and I run that. It now changes the way it looks on the screen, doesn't it? What happens if I use the kind of swervy-worvy brackets? Now these you'll learn all do very different things inside the program. But you'll notice it again prints it, but it puts them, it puts it there. So really, the answer that we're supposed to use is those brackets, and when we run that, it just gets rid of the brackets altogether and just says the words "Hello Andrew" that's inside. So we don't need the brackets, but the brackets kind of help. They help structure it. Now you'll also notice this when purple does this print command. If I change that to being a capital P at the start of it, and I did print like that, what happens then? Well, it brings up an error. It doesn't recognize it. Doesn't know what to do. What happens if instead of using print like that, I do print as all capitals and I run it? Well, that also brings up an error. So it is quite particular. It does want print in lowercase in order to get rid of that error. Print's not an option. Now, what happens if I change the quote marks from a double rather, to a single? Does that matter? Well, when I run it, no. So there are bits of this code that it's very particular about, like putting in the command name precisely. And there are other bits where it's not as particular. So what I want you to do now is just to experiment with that, to do a kind of a modify exercise and see if you can alter that code so it prints different messages. Maybe do 2 or 3 prints so it prints different messages. And I'll pause while you do that. Now, hopefully you've had chance to experiment and have a go at that. So if I now change this to go hello world again, and then I do a second message and go, what a beautiful day. And then I do a third message that says, we are going on a bear hunt. Some of you'll know why I picked that. It's my children's favourite book. So, hello world, what a beautiful day. We're going on a bear hunt. So you've got those 3 kind of statements where we've managed to alter the code, where it's come up with those particular sets of instructions. Now, I want to do a make exercise. And on this make exercise, what I want you to do is to do 3 lines that say, hello, my name is, and then your name. I am such and such an age. And a third line that says, and this is my favourite colour. And I'll pause the video while I give that a go. So then, hopefully on that one, you did something like this that says, hello, my name is Doc. And then next to that, you could go print, my age is, and then I'll put in something 45, say. And then we could do another print that says, my favourite colour is blue. And when I press run to those, each of those appear on the screen. Now, you can see that what those are doing are a sequence of instructions. They're doing one thing after another, exactly like we were doing with a cup of tea, but in a completely different context. It's saying, do this, now do this, now do this. Do, hello, my name is Doc, then put my age is 45, then put my favourite colour is blue, and it puts those on the screen in that order. It puts them in a sequence. So a sequence is when instructions are followed one after another in the order they're written from top to bottom. Now, what I'm interested in next lesson is, can we change that set of things so that instead of these being statements that are appearing on the screen, hello, my name is Doc, it asks me a question and says, what is your name? And it says, what is your age? And it says, what is your favourite colour? But at the moment, it's not interested in my answers. It's a bit like that friend that just wants to listen to themselves. It puts up all those things on the screen, but it doesn't wait for me to type anything in. And there is a command that does that, and that's what we're going to look at in the next session. So, just before we finish, picking up the key answer, the key concept that we threw in today, well, there were two. The first one, what is an algorithm? And the second one, what is a sequence? I'll just give you a moment to pause and think, and then we'll go through those two answers. What is an algorithm and what is a sequence? And the answer will be that an algorithm is a step-by-step series of instructions, and a sequence is when instructions are followed one after the other in the exact order they are written from top to bottom. Coding is a great skill to have learnt, and I'm glad that you've followed me through for this first session. We've made a piece of code, we've looked at code that was blocks, but then we've translated it into real kind of hard code in terms of putting it into Python, in terms of lines of text. And next session, what we're going to do is take that a step further and start building more sequences of code where it comes one after another, and pick up those ideas that we've covered today and build on those. And this will continue for about 8 more sessions.